So your book talks about finding the inverses of 2 by 2 matrices. Now we're going to try doing it for a 3 by 3 matrix. First of all, let me just remind you, 2 by 2 matrices, all you need to do is to find the inverse of P. Let's call this A, B, C, D. All you do is you go 1 over the determinant of P, which can be found this way, AD minus BC, and then you go ahead and plug in the values here, D minus B minus C, A, and all you do is you simplify that, and that will give you the inverse of P. Now let's try doing a 3 by 3. It's a little more complicated, but it's worth it, and you get extra credit if you try this one. So the first step, there's 5 steps we'll be talking about. The first step is you find the determinant of the 3 by 3 that you've been given. We have A, B, C, D, E, F, G, H, I. So it's simply, you take your A, you ignore this and that, and so it's A times E, F, H, I. So A times E, F, H, I, and then you do minus B, D, F, G, I, plus C, D, E, G, H. Notice again, you pick the first letter, you ignore those, and you now have a 2 by 2. You find the determinant of that, and then you multiply A into that determinant. You do the same with B. Notice that the signs alternate from the second, which is minus B, and then here plus C. That's the first step. The second step is to transpose your matrix. So A, B, C, D, E, F. You're going to transpose it into a different form. We're calling this one R. This system is labeled R. So what we do to R is we rearrange it so that A, B, C is now written downward, A, B, C. And the same thing with D, E, F, D, E, F, and then G, H, I. That's the same thing we're doing there. That's step 2. Step 3 is we find the matrix of cofactors by first calculating the matrix of minors. What we do at this point is, remember in this step, all we did was, we took the first letter, and then we ignored that and that. Now remember, this is the transposed form which we got from step 2. What we do at this point is, it's as though we're taking A, but we're not going to write A outside. We're only going to write E, H, F, I. That gives us M11. What this means is that each position here has something to represent it. This is called M11 or M12, M13, M21, M22, M23, and then M31, M32, and M33. That's, for each of these locations, we're going to calculate a value here associated with it. So it becomes, for the first one, when we're looking for this right there, what's going to be there, which is M11, what we do is we ignore that, and we just have EHFI. We do the same thing for the second one. When we're looking for this, we ignore that and the one right there. So we have BHCI. And then we take the third term, we ignore that, and we have BECF. So now we use that same mechanism to find M21, M22, and M23, M31, M32, and M33. That's how we do that part. The next step is to apply the sign changes, and this is unique now. This is step 4. The first and third term here will remain the same. So essentially we would have M11 stay the same and M13. However, M12 will become we have minus in front of it. And then we also do the same for that, and for that. So notice that the one in the middle here, the 2 at the ends, and then the one in the middle. Those who experience sign changes. We will take those sign changes and use that to solve the next step, which is the inverse of R is 1 over the determinant of R, and then all we have is the adjugate of R, which is found right here. After you do the sign change, you take those values and you plug them in. Let's do a quick example right here on the board. The first step, well, first of all, the question we're answering is find the inverse of this. So minus 2, 1, minus 1, 2, 0, 4, and then we have 0, 2, 5. If you're told to find the inverse of this 3 by 3, what you want to do first is you find the determinant of this, which is simply found when you do minus 2 into, you have 0, 4, 2, 5, then you have a minus, and then you put a 1, and then you have 2, 4, 0, 5. Remember, all I'm doing is I took the minus 2, and then I ignore this and that, and this is what I use. And then I take the 1, I ignore that, and I use this and that. And then I take the minus 1. Remember, there's a plus here, but when a plus and a minus meet, the minus takes the place there. And so we have minus 1, and then we ignore that and that, and so we have 2, 0, 0, 2. Again, that's the first step. So you go ahead and solve this, and you realize that your determinant for this system, which we're going to label S, will simply be a 2. That will be the solution for the determinant. That's step 1. We did this. Step 2, we're going to transpose our original expression right here. Well, we're going to transpose that. And what happens is it becomes, in step 2, let me get a new marker here. Step 2, we get minus 2, 1, minus 1, and then 2, 0, 4, and then 0, 2, 5. That's all we do in step 2. We've transposed our matrix. The third step, what we want to do at this point is we're going to move over to we're going to clean this first, and then because we're done with these first 2 steps, so we're going to take this down, and we're going to do the third and fourth steps right here. So for step 3, what we do is we find matrix of cofactors by first calculating the matrix of minors. For this one, S, T, remember that we transposed S, and that's what we got. For this step, all you do is you find the M11, and we're going to just use a table form here, so we keep track, or tabular form. We have M12, and we have M13. And then we do the same thing. We have M21, M31, we have M22, M32, we have M23, and M33. And what we do at this point is we take EHFI. Remember again, all we did for that one was we're looking for M11, so we ignore everything on this line and that, and all we have is EHFI. So for our case, when we're looking for for M11, so it's like we're looking for what will come into this spot. We ignore that, and we just use these, and then we get a 2 by 2 matrix here. So we get 0, 2, 4, 5. And then we do the same thing for M12. We're looking for the term that is going to go right there, and we're going to ignore that. We're going to ignore that, and so what we have is 1, 2, minus 1, and 5. So we have 1, 2, minus 1, and 5. And I solved some of that on here, and I'm just going to go ahead and write the remaining details when you follow that format. For M13, you're looking for what is going to go here, and so you ignore everything there and down, and you have BECF. And for this one, what we're going to have is 1, 0, minus 1, 4. And then for M21, we have 2, 0, 4, 5. And then we have minus 2, 0, minus 1, 5. And then we have minus 2, 2, minus 1, 4. And then we have 2, 0, 0, 2, minus 2, 0, 1, 2. And then we have minus 2, 2, 1, 0. So notice that each of these will fit perfectly into one spot in the 3 by 3. So when you find the determinant for each of these, so that one will just be 0, minus 8. Here we would have 5, minus 2, and so on. So you find the determinant for each of these. And the numbers we work out here, we would have a minus 8 when we simplify this one. And then we'll have, in this one, we would have a positive 7. and then we'll have a 4, and then we'll have a minus 10. Well, let's look at this one for a second. We have 5 times 2, that's 10. Okay, so we'll have a positive 10 here, and then over here we'll have a minus 10, and then we'll have a minus 6, and then we have a 4, a minus 4, and a minus 2. Notice that's step 3. Step 4 is when you apply the sign changes. So remember, 1, 2, 3, 4. We're supposed to get 4 sign changes. The first one occurs right there. We get a minus there, we get a minus here, we get a minus there, which makes it a plus, and we get a minus there, which makes it a plus. So now that's step 4. We just applied step 4. We applied the sign changes. That's step 4. So let's go ahead and we're going to move on to step 5. And I'm going to clean step 3, so I do step 5 there. For step 5, all you do at this point is you use the formula. So again, the inverse of, in this case, is S. The inverse of S is simply 1 over the determinant of S into the adjugate of S. And the adjugate of S is found when we apply the signs. And that's minus 8, minus 7, 4. And then we have minus 10, minus 10, 6. And then we have 4, 4, minus 2. So the determinant of S was 2. And so what we have now is we have 1/2, and we multiply it into each term over here. Each term is multiplied by half. So what we have as our final answer will simply be minus 4, minus 3.5, minus, just a positive 2, and then we have minus 5, minus 5, 3, and then we have 2, 2, minus 1. That's all you have to do to find the inverse of the 3x3 matrix that was given here. 5 steps. It might take you a while, but it's worth it, and I hope that it helps build your math skills.